Hi, everybody. Good morning. My name is Vikram Hosakote. I'm a senior software developer at Cisco Systems. Firstly, thanks a lot for the vBrownbag crew and OpenStack Foundation for this talk. So I'm going to be talking about replacing Neutron's Dnsmasq with Cisco's product called Cisco Prime Network Registrar, and I'm going to cover the different areas in the product, like design, architecture, and scale numbers. And please feel free to ask any questions you have. Let's get started. So the theme for Cisco here in this summit is build, deploy, scale, and connect. So Cisco builds and does upstream, deploys cloud, the scale, and then, of course, connect with the community. Before I start, I would like to congratulate my daughter. It's her first international trip. She's here in Japan. She's just 4 months old, so it's her first international trip to Japan, and also it was her first train ride in the bullet train, and she almost fainted. Probably, yeah, she cried a lot when the train accelerated like to 230 kilometers per hour. Yeah, she's doing good in the trip. And also a big shout out to all the fellow Ciscoites here. Thanks a lot. So this is the agenda. Introduction to the product, what's DHCP and DNS, Dnsmasq issues in Neutron today, problem statement, and then Cisco's solution, design and architecture of the product, and difference between Dnsmasq and Cisco's solution, and finally scale testing approach and the scale numbers. So the introduction is about addressing DHCP and DNS scalability issues in OpenStack Neutron with a highly scalable enterprise class RESTful solution using a Cisco product. And the product we used is in the Cisco Prime suite. It's called Cisco Prime Network Registrar. It's a highly scalable enterprise class DHCP DNS and an IPAM server. That's the GUI, how it looks, and it's all configured through REST APIs. So what is DHCP and DNS? So they're basically bootstrapping protocols that run when a VM comes up. So when a VM comes up, it's going to send DHCP discover, and then the DHCP server is going to reply with an offer, and then client is going to request the IP address, and then the lease is issued with a particular expiry time. And then DNS converts a domain name like openstack.org to its IP address. And they're very important in any VM. If they're down, then VM loses network connectivity and pretty much cannot be accessed. So Dnsmasq issues in today's Neutron is that there's one Dnsmasq process for each DHCP network, and it reloads and rereads its config file in varlib Neutron DHCP every time a DHCP port is created. And it's not RESTful, so it has to be started using CLI and then pass a lot of arguments like host file, and then IP address, subnet range, lease expiry, and it takes a lot of arguments, command line. And it does not really scale for an enterprise cloud. So it's really not enterprise class. So this is a little animation that shows the problem of Dnsmasq in today's Neutron deployment. So this is an empty network node, and every time we create a network, we get a QDHCP namespace created. And a Dnsmasq process is spawn and listening for DHCP requests. And we create three such networks, so we have three namespaces now. And so if we create, say, 2 ports in the first network, so Dnsmasq is going to reload twice. And say we create it on the second network, it's going to reload twice. And same with the third network. So if you have if you have an orchestration script like Ansible or Puppet that's creating a lot of ports and networks, like one after the other, without much time between the creation, then this is how it's going to look. They all keep reloading as their ports are created, and that's okay with three networks. But when there are a lot of networks, they do actually consume a lot of CPU memory and disk resources. So that's the problem with Dnsmasq. They keep reloading. And what we found in our lab testing is the number of Dnsmasq processes and reloads, they both increase over time when the number of ports and networks increases. So that's not really scalable with lots of DHCP networks and ports. So this is just a screenshot of the PS output that shows six Dnsmasq processes. So we found out that Dnsmasq does not scale in our lab testing, and we decided to replace it with Cisco's enterprise class solution. So this was the problem statement for the plugin we developed. Replace Neutron's Dnsmasq with the DHCP driver that's highly scalable, enterprise class, and uses Cisco product. It's easy to operate and supports REST API, and it's very easy to install, deploy, and upgrade. So as part of our project, we use CPNR, Cisco Prime Network Registrar, to develop the following modules. So we developed DHCP driver, which is very easy to be enabled. It's just a config variable in the DHCP.ini file. And there's DHCP and DNS relays that relay packets between VMs on the compute node and the DHCP DNS server. And then we also have Ansible Puppet scripts to automate installation, upgrade, and deployment. And finally, a testing tool to scale DHCP and DNS by simulating clients. So this is the design and architecture. So each network node, we have a relay that's going to listen to each DHCP packet from each network, and that's going to relay it upwards, upstream to the Cisco Prime Network Registrar server. And then the server is going to reply, and relay is going to relay southwards back to the VM. And this is how we can visualize for multiple networks. So we have a network worker thread for each namespace, and then each relay is going to take care of the packets of that particular network, and they're all sent to a single server outside the network node. And it's configured using REST API by the DHCP driver. So this is the difference between today's Dnsmasq and Cisco solution. So as we can see on the right, it's one instance per entire network node. It doesn't reload when every port's created. It supports REST API. It's enterprise class and cloud ready. It's very, very highly scalable. And the recommended limit is 2 million clients. And it uses dedicated resources on a separate server. And of course, it's developed and tested by Cisco. I'm almost at the end. So the scale testing was pretty challenging. We couldn't use Nova to send a lot of DHCP packets, so we ended up using open source tools to simulate what Nova does. We use tools called Perf DHCP and DNS Perf to simulate DHCP and DNS clients. And we were able to scale up to 10,000 clients and almost 2 million packets per scale test. So this is the comparative graphs that show the average time to receive a DHCP lease, and also the packet drop percentage. So we can see here that the CPNR takes like 0.11 second to get a lease, I mean to issue a lease, and Dnsmasq is almost like 94 seconds with 10,000 clients. And packet drop is also great with our plugin. It's almost 0% up to about 2,500 clients, and then the drop is about 61% with 10,000 clients. But Dnsmasq almost doesn't reply at all with 10,000 clients. And this is the graph that shows network scaling. So the previous graph is with one network, lots of ports, and then this is about lots of networks with fixed number of ports per network. So here we can see clearly that CPNR issues lease faster than Dnsmasq, and then also packet drop is very less compared to Dnsmasq. And this was done up to 10,000 clients, so 2,000 networks each with 5 DHCP ports. And DNS scaling was done using DNS perf, and our driver had almost 0% drop and almost less than one millisecond response time. And we scaled up to 1 million DNS queries. So for more information about the driver, so there's a blog about it on Cisco DevNet, and that's the email address. You can contact us, and it's in the process of getting upstream. The driver, the relay, everything is ready and tested inside Cisco. It's going to be upstreamed very soon. That's pretty much it. Any questions?